the links here for all the presentations. So if you just want to kind of skim through and look at some of the features, high level, you can do that as well. So what we're going to do, very quickly, let me explain what we are trying to do here. I'm going to show you a use case of, let's say I have a bunch of documents. I want to prepare them to use with LLMs. Basically, I'm doing a RAG pipeline. So RAG is, as you know, right? So you probably know this already. So let's say LLMs are trained on the data, on the internet data, right? So they don't know anything about your private data, but they have a lot of knowledge. They understand how the language works. So what we are going to do, we have internal documents. We are going to clean them up and then send it to the LLM and ask questions. Right? This is a very popular use case. This is how a lot of people start using LLMs. I cannot do RAG because using internal documents, right, and asking questions. So the question is, how do you prepare the documents from, say, local PDFs, right, to a format where you can send it to RAG? Yeah, so that's what you're going to show. So very quickly, in this space here, right, we just come here, go ahead and grab this notebook. So section 1 is what I want to demonstrate right now, which is screen is visible. So you can actually go and start the notebook. So we can do option 2 real quick, right? And you can just click on Colab. Go ahead and open Colab right now. Right click, new tab or whatever, right? And then once you have it open, right? Again, so we are doing 2. Once you have it open, you can simply say run funnel, right? So this way it will kind of start running. It'll go through installing the packages. So you can just say do run all, and yeah. But I am going to walk you through step by step what it's doing. But just to save some time, just go and pick up the run, say run, right? And it should just keep going. And I actually ran this, just now, so I'm going to quickly walk you through the steps. So here's basic idea. The workflow is like you have a bunch of PDFs. You're going to first extract text data out of this, right? And then we are going to do some cleanup. And as you know, before we submit the data to LLM, we have to split the PDF into sections or chunks, and we are going to do that too. And then also, when you create chunks, I'm going to show you how to eliminate duplicates. So this is pretty interesting because if you have duplicate documents, right? That just adds to the data size. We don't want that. So the toolkit actually has duplicate elimination. And then finally, I'll show you how to create images. So at this stage, your document is ready to go to the line. So that's a high level process. I'll walk you through. So I'll also kind of show the slide just so you can sort of see the concept. If something is hard to see from the notebooks. All right. So here I just have a very simple PDF, so you can sort of see the products, right? It can handle complex PDFs, but for the demo purpose, I just created like 2 simple PDFs. I call it Earth and Mars, right? Just some basic facts about Earth and Mars, right? And we are going to run them through the site. Yeah. So first thing I'm going to ask is, okay, so here's my PDF. Go ahead and extract text. And you can see when I run it through this step, so this is my PDF document, you can see it's extracting documents in sections, right? Which is important because it's keeping the structure of the PDF. That is important. Yeah.
Will it work with tables as well? Tables.
Oh yeah. So yes, great question. On the PDFs, you can do tables. You can even do OCR. Like if you're like handwritten PDFs, right? You can even do OCR. So it's pretty capable. Yeah. So table data, OCR data. Yes, absolutely. Good question. Thank you. And when we extract PDFs, you can see it's actually extracting the section, so you can sort of see it like sort of header, right? Goes header, and you can sort of see right the type, the subtitle. Then the next one is a paragraph. You can see the type paragraph right here, and it also extracts the lists like bullet list, and then it says list item, right? So it's actually extracting text, but still keeping the structure intact, right? Which is important. So this is the first step. Now, if you're running your Colab document, so right again, in the first few cells, we are kind of figuring out if you're running on Colab, you're installing, right? We are installing our dependencies. By the way, right, I'm only installing, these are 3 dependencies I'm installing. Zoom in a little bit, right? So you can see it's a data propagate transforms, and I'm also installing the array version. But so that's all we do. A simple pip install, and that goes all libraries there. Sometimes when you do a pip install, sometimes Colab will ask you to restart runtime, right? You can just skip that, right? It's fine. You don't need to restart runtime. You should just work. Anyway. And then the first few steps, again, I'm just defining input directly where the data is coming from, right? So just a typical input output setup. Let me skip ahead to show you where the extracting PDF. So this step is called PDF to Parquet. So you're wondering why we are extracting PDF into Parquet. Has anyone used Parquet format here? Parquet file format familiar? So we are pretty familiar, like JSON format, CSV format, right? Those are human readable, but they're not very efficient for computers, right? Because right? Parquet format is designed to be highly efficient format for query. It's very compressed. It's very efficient to store data in Parquet. So that's why Parquet is the preferred format for all the intermediate data. So our PDF data, right, is being extracted into a Parquet format. That's what PDF to Parquet. So if you're running this code, you'll sort of see, right? Here's my PDF, right? It's reading from my input data. You can see here, right? And basically, this cell just sets up, right, the extraction of text from PDF. That's it, right? So again, just look at the data. It's basically running, right, the PDF to Parquet module to basically extract text from PDF. That's it. You let it run, right? And then at the end of the run, you can see, right, when I print out the output, step 4.3, you see I have two entries, master PDF and output PDF, and you can kind of see the content right here. See, this is actual content that we extracted, right, the text content. And then somebody is asking about the tables, see right here, right? So you can direct any tables, we have very simple PDFs. But if you have tables, it would show up here, right? So you can direct tables and say how many tables like that. And our documents are very simple, just one data. So you see there are a lot of metadata being extracted as well, right? The hashing of the document, size and everything. These can be handy if you want to do comparisons, which we'll show you there. Right. So that's it. So first step is basically, we have PDF files, we extract them into the text. Right? Very good. And then also I'm just in the next step, I'm just printing out just so you can sort of see how it's extracting documents. I'm not going to go too much into the detail here, but you can sort of see here, right? It's like header, it extracts the header. It also shows you, shows you the bounding box, like what the bounding box is, what's the page, and actual text of the header is masked. Anyway, so you can sort of see like it's actually keeping the structure of the document as it's reading the text, which is very important. Anyway, and you can sort of see, right? Here's a paragraph, right? You can see type paragraph. Anyway, just a debugging flow, just so you sort of see it, visually what's going on with the data. Very good. All right, let's go to the next section. Right. So the next one, basically, we're going to split the document into chunks. Let me show you what that looks like graphically. Right. So here, if you look at this, so we extracted data. Next one, we're going to chunk. Yeah. So what chunking is all about is I have this PDF. Let's say your PDF is say, 10 pages or 100 pages long. We don't want to keep the whole thing as single unit, right? Because it's not very efficient to search a 100-page PDF. What we want to split is going to split them into chunks. Now you can ask, okay, so how am I going to split the PDF? Is it like page by page, like one page, one chunk? That's a popular approach to it. Say, I have 100-page PDF. We're going to split it into 100 chunks. Each page is a chunk, right? Another option, that's what we are doing here, is basically what we call natural text boundaries. So actually, the tool looks at the PDF and it extracts their paragraphs as one chunk. You can say, right, this first paragraph right here, this becomes a chunk. All right. Second paragraph, one chunk. This bullet point, right, one chunk. So I think this makes sense a little bit more because you actually is context aware, right? You're not just randomly saying this page, one page at a time. Actually looks at the text boundaries and split them pretty good, right? And this is called chunk. So again, this is built-in module. You can configure it in any way, just like the default behavior is text boundary. All right. So where is it in the code? Let me show you real quick. So we're running the code. So section 5, step 5 is where the chunking happening. Again, let me show you real quick where the chunking code is. Like again, you can see, right? The dot chunk transformation. We're simply picking over the module. That's it, right? And once we are done, right? Again, remember. So you imagine a pipeline. So the first step was extracting text from PDF. This is the second step. Yes, we are now chunking the text, right? And once you sort of look at the output, you sort of see here, right? Remember, I sort of started with 2 PDFs, and then we ended up with 8 chunks. Remember, my PDFs are like 1 page, right? So they're pretty simple. In a real world situation, you may end up with hundreds of chunks. That's what you should expect. And if PDFs are large, like 10 to 20 pages, each paragraph and section will be a chunk. Very good. And now, again, I'm just printing it out here. You guys will see here, right? Remember, I started with 2 documents, and you can see each document has multiple chunks, right? So master PDF, has multiple chunks as we would expect, and so so is editor PDF. So we have 8 chunks. Very good. And again, I'm just printing out the results so you can see, right, how the data is being split. And basically, you see it's being split across text formats. Pretty good, right? So again, not rocket science. It's stuff we do. Before we do processing documents with LLMs. Just so the idea is like tool. Will help you do this very easy. Just few lines of code and then you up and run. Right. So this is actually interesting. So now I have chunks. Now, let's say I have some duplicate data, right? And this is bound to happen, right? There are thousands of documents. There's going to be a bunch of duplicates. We don't want duplicates entering the pipeline, right? Because A, they increase the size of the data, and B, when you're training models, duplicate data is actually not good because it's going to force the model to what we call overfit, right? Which is training the same data over and over again. So we don't want that. So how do you do duplicates? Very simple. So if you look at this one here, so you can do duplicates on the document level or the chunk level, right? So I'm here showing the chunk level we do because it's kind of easy to understand. So if you look at our both documents here, this first paragraph is exactly the same. Right? On both documents, exactly the same. So what I'm going to do, I'm going to run through dedo, and only one of them will come out. So when I do the exact dedo, we can see, right? Only one of the chunks. Okay, how do I do this? Let me show you the code real quick. All right. This is step, right? By the way, before we do dedo, we have to create like a hash of the chunk type. That's how we identify duplicates. So the step 6 basically create a hash for the chunks we just done. That's it. Right? So the step 6 basically you can see here, right? We are creating and I say I'm creating a hash. Which column I'm creating on hash on? The contents. Actual content of the chunk. Right? Because we actually want to identify the duplicate content, right? So we run this transformation, and if you look at the output finally, you see, let me show you here, right? You'll see the hash is being calculated. So once you do the hash, as you know, it's pretty easy to compare. Like, hashes are the same, duplicates. So that's what it does. So it doesn't do like the entire text comparison, which is it's kind of very expensive, right? If you have a large number of documents, so what they do is they do a hash computation and then compare hashes. Much more efficient. Right? And that's why we create the hash as the next step before you can do it. All right, so this is done. So step 7 is where I'm doing the dedo. In this dedo, I'm calling it exact dedo. The reason I'll tell you why in a second. If the chunks are identical, as in like exact duplicates, remove it. How do they do it? By comparing the hash. Right, very straightforward. So again, you can see here, right? I'm doing there's a exact dedo module I'm running it, right? So after I run this, you can look at the code here. See, I started with like 8 chunks, right? So remember, we had 8 chunks before, right? After I run the deloop, I have 7. Right, so remember the one identical chunk is now ready. Very good. Yeah. So again, like I said, pretty much built in, right? Just run this, and then it will examine. So now you imagine like thousands of these chunks I want to process. It will go very quickly because why? You're getting a hash from that. Very good. All right. Here's another one I'm going to show you. Right. Let's get the concept here. So exact dedupe, we get it. Identical chunks removed, right? But there's another thing, and this is kind of my favorite feature actually, is sometimes you have chunks that are almost the same. Not exact, almost. Right? So take a look at these 2 paragraphs. Right? So it basically says there's only one word that's different. Right? So for all practical purposes, they're the same. Right? So imagine, like, let's say you have documents, right? Exact document, somebody reviews it and then updates the date, saying last update at date. So basically, you have let's say you have 200-page documents, exactly the same, only one line is different, the date, right? So there's nothing else. The exact content is exactly the same. So we're going to remove that. Now we cannot do that by doing exact dedupe, right? Because exact dedupe actually compares the hash. Even if like one character is different, it won't catch it. And this is where the fuzzy dedupe comes in. That's the name fuzzy, right? They will actually look at similarities and eliminate similarities. Pretty good, right? So when I run the fuzzy dedupe, you'll basically go and say, all right, these 2 chunks are pretty identical. I'm going to eliminate them. Right. Let me show you how it's done. In the code, if you look at the code here, step 8, fuzzy dedupe. Again, in the same deal, we have a fuzzy dedupe module, right? It's called dedupe, and I'm running this here. And so, by the way, if you're playing with this, there's like a dial you can actually play with. It's called a threshold. So think of it like a dial, right? So when you do fuzzy dedupe, remember, it's not exact. So you cannot define how aggressive you want it to be. Do you want to be more lenient, as in like let kind of document through, or you want to be very strict, right? So and this dial actually controls the behavior. And there's not like a right setting, like so I think the setting goes from 0 to 1. 0 meaning like very right, more free form. 1 meaning very strict. So you can want to find the number that works for your documents. So here I just went to 0.7 because that's what works for me. So this is something you can play around a little bit too for your environment. And the other parameters are pretty just default. You look at the documentation to see if you want to keep them. Honestly, this is probably the only one. Hopefully, you need. Right? All right, let's look at the results. So I'm running this. Right, goes and run through. So here, I started with 7. Remember, right? I started with 8 chunks. One was eliminated with the exact dedupe. So now I have 7. In the 7, after the fuzzy dedupe, I have 6. 1 is right. So that this exact chunk we just talked about, right? This one here, the right, the one that's a B, right, other solar system, and the B solar system. Just one word different. Now remember, here I'm showing you from a chunk level. You can do the exact same thing at the document level, right? Let's say your documents are like almost the same, maybe like one word different, right? You can just do it. So this can really cut down your input size quite a bit. It's very, very handy. All right. Final thing, I'm going to show embeddings, right? So imagine, right? Imagine our process, right? So we kind of went through the whole pipeline, right? We extract our text, we split them into chunks. We just went through dedupes, right? Exact dedupe and fuzzy dedupe. So at this point, our documents are reasonably in a good shape. So let's say, okay, let's vectorize that and send that to a database or LLMs. And that's the final step. So, and I'll show you right here very quickly. We're going to be running this. Step 9 is really embeddings. So again, we are embedding embedding module, text encoder. you can pretty much plug in any open source embedding model. And in this case, I'm using, which one am I using? Let me check here. Right, I'm using sentence transformer, mini Llama, right? An open source one. It's pretty small model, pretty decent model. You can pretty much plug in any open source model you want here. It will automatically download. Very convenient. All right, final step. So I'm going to show you how to run text encoding. Again, you're using our mini Llama model as our encoder model name. Basically, once you launch, we run. After we run through, you will see there's a new column created. You will see at the end. Right? See embeddings. Right? So basically, every chunk is now encoded. And embeddings are important as we need embeddings before we can do text search or semantic search. So at this point, right? So my documents are split into chunks. Video to done, and we are embedded. So, and that's the final step. So hopefully, right, kind of give you a sense of, right, all of these modules are kind of built in. So we're kind of going through this, maybe consider, consider checking the model out. Just a quick word on embeddings, right? If you're wondering, why we need embeddings, right? So what does embedding do? Embeddings basically takes a word as input and spits out a vector. Vector is just a bunch of numbers. But they don't just spit out random numbers. There's actually meaning to this, right? So, for example, when they map a word cat, right? Let's say it's only mapping in two-dimensional space. So my cat kind of maps to here, right? Then I'm mapping, say, banana. And I'm converting a word banana into vectors. So as the model knows, right, the words cat and banana, right? They don't really happen next to each other. They're kind of two different things. One is a fruit, one is a pet. So typically what it'll do is like when it maps it, it'll kind of map it, away from the cat. So let's say cat is here, banana is here, right? Next I'm mapping the word dog. So now the model knows dog and cat are mentioned pretty, they can happen, pretty close in the text, right? These models are trained. So as they read the text, they know a lot of the time the word cat and dog are kind of mentioned close to each other. So now when it's mapping the word dog, it's going to map close to cat, not next to banana, because it wouldn't make any sense, right? Okay, so after all the mappings are done, you can sort of start seeing these natural groups start to form, right? So, like for example, this group represents the pets, right? And then here, like if we map fruits, this group represents the fruits. So right, so naturally, just the way the embedding models are trained and they work, when they map words into vectors, they naturally kind of give it meaning, right? Which is pretty amazing. Is that going to make sense and this is why embeddings are very useful. Mind you, here I'm showing you two-dimensional X and Y. In real life, embeddings can be, like 300 dimension, 1,000 dimension, 4,000 dimension, whatever, right? So we cannot visualize it, but the math is exactly the same. So we can visualize maybe 3 dimension, that's it, right? But yeah, math is the math, right? Whether you have 3 dimensions or 300 dimensions. Anyway, so basically this is what we are doing. When you're creating embeddings, we're creating this, this kind of representation of a text. Doesn't need to be text. Embeddings can work on like images, like audio files, pretty much anything you can map to vectors, right? So why do this in the first place? So let's say, remember this diagram. So I already mapped all the words into embeddings. So now let's say I'm mapping the word, say, pineapple. Now, as you know, when I map the word pineapple, it's going to map somewhere here next to the fruits, right? Because that's a natural, grouping, right? It probably won't map to the pets, because most likely, right, you don't have a lot of text mentioning pineapples and cat in the same sentence, right? So when I map pineapple, so it comes close to the fruit fruit category or fruit group. So now when I'm searching for pineapple, I may get results for pineapple, and also I may get results for like apple and banana. Right? Why is this useful? Like for example, you can do the same thing, right? You go to open your Google Maps, Apple Maps, search the word, say donut, right? Let's say you want to Google donut, you search for donut, right? When they show you businesses, they will show you donut businesses. And maybe they will also show you some ice cream shops. Right? And I'm wondering why, I search for donut, why am I getting ice creams, right? Because remember, because they're in the same vicinity, right? So when you search for donuts, most likely they're not going to show you ramen places. Unless there's a shop that's doing donut, some sort of donut ramen, right? Which, okay, you just get the idea, right? So when you search for a thing, you don't just get the exact one, because that's just in keyword search. We also get context-aware searches. So I search for donut, I'm getting dessert places like apple places, so ice cream places, coffee shops. Anyway, so that's how it's powered by. And this is usually called vector search. So instead of doing keyword search, we all know keywords, right? You search for keyword in a document. Vector search can actually give you better results, because why? It's not looking for just exact matches, it's looking for meanings or a context. It's pretty good. Anyway, so is it going to make sense? Right? Yeah, kind of embeddings, why they're great. Yeah. Anyway, so final step here. Remember, I had chunks, right? So I went from PDF to chunks, we did all the cleanups, right? And then finally convert them to embeddings. And when I do a search, now the search can actually return relevant information. That's a basic idea, right? All right. Very quickly, embedding models, right? Again, I talked about this. There are a lot of good embedding models. Some of them are proprietary, like for example, if you use OpenAI, right? They have their own embedding model, which is very good, but you can only access it through API. And you cannot download the model. Same Cohere, right? And so they go, they have their own. But there are open source models available too. You can go to like Hugging Face, you go search for embedding models, go to Hugging Face, and they basically rank these models, right? And you can see some of the models are like, right? By the time I took the screenshot, the highest score was 66. Now probably it's even higher, maybe like 70s. The models keep improving, right? But you can download the model, any model you want to download, you can download it. Which is nice about it, right? So we are big proponents of open source, as part of the AI Alliance, right? We are actually building an AI stack full of open source components. So open source is actually pretty good. All right, guys. So that is it, right? Just want to show you a quick feature overview of our data prep kit. Again, open source Python. My take is, we all have to do all this data wrangling when you prep your data. So hopefully this toolkit can save you some time. That's it. So thank you so much. I don't know if there are any questions. Let me know in here or in Zoom. You can also shoot me an email at any time. Thank you so much. Yeah.